Hi goodies, hope you're having a good day. And today I would like to wish you a very happy new year. I believe you all had an amazing new year celebration and we all are stepping into a new year. So I hope you guys have the best year ahead. And I would also like to remind you that from today onwards, don't go and write 2024 in your books because from today onwards, let's write the date as 1/1/2025. I keep forgetting writing that, so I don't want you guys to forget that. Okay? So today, let's get into a new topic that is prime numbers and composite numbers. So first I'm going to introduce prime numbers to you. As usual, let's see the definition first. Prime numbers means a whole number greater than 1 which has only two factors. If you see, I have underlined the word two factors. Yes, is something clicking? We discussed what are factors in our very last videos. Factors. Yes, let's once again recap that. What are factors? Factors are any number which can divide any other number without leaving a reminder. And I hope you remember the examples that we discussed. For example, let's take 10. 10. And let's take the second number as 2. I can divide 10 with 2 and get the answer as 5 with no reminder. So 2 is a factor of 10. And I hope that you guys know already. Now let's come back to our case of prime numbers, and here we are using the word factors again. Prime numbers will have only two factors, and let's see what are those two factors. One is the number 1 and second one is the number itself. If it's not clear, don't worry, let me give you an example. Let's take the number 2. Here, if you just refresh or remember your multiplication table, the number 2 can be divided by only two numbers properly. 2 divided by 1, which is 2 itself, with no reminder. So 1 is definitely a factor of 2. And 2 divided by 2 itself, which is 1, and again no reminder. So 2 is also definitely a factor of 2. Other than that, if you just go through the entire multiplication table, you won't see any number multiplied by any number equal to 2. You just have 1 times 2 is 2. Right? Do you get 2 anywhere else? No. Which means 2 is such a number that it has only two factors. One is 1 and the second one is the number itself, that is 2 itself. Okay? So, prime numbers means a whole number greater than 1 which has only two factors. So, let's take one more example. This time, let's take 5. If you again recollect your multiplication table, 5 comes only once in the multiplication table, and that is 1 times 5 is equal to 5, which means I can divide 5 with 1 without leaving a reminder. I can divide 5 with 5 itself without leaving a reminder. And these two numbers are the only two factors of 5. So 5 is also a prime number. So I hope now prime number is clear. Now let's see what is the next set of numbers. So now the next set of numbers that we are going to learn are composite numbers. Let's see what are composite numbers. As a definition, I'll say numbers that has more than two factors. So if you remember, prime number definition was numbers which have exactly two factors. But composite numbers are numbers which have more than two factors. Let's not get confused. Let's look into the examples first itself. I have chosen the number 4. Now, if you see, or just refresh the multiplication table in your mind, 1 times 4 or 1 multiplied by 4 is equal to 4, which means I can divide 4 with 1 without a remainder. I can divide 4 with a 4 without a remainder. These two are factors of 4. Same way, 2 multiplied by 2 is also 4, which means 4 can be divided by 2 without a remainder, which means 2 is also a factor of 4. So, now itself I have 3 factors for 4, 1, 4 and 2, which means it's not obeying the rule of prime number. One factor is 1 itself, second factor is the number itself, that is 4, and then there is one extra factor, that is 2. So, not a prime. Then what else? 4 is a composite number. Let's look into one more example. 12. 1 multiplied by 12 is 12, which means both 1 and 12 are factors of 12. I can divide 12 with 1 also. I can divide 12 with 12 also without a remainder. So, yes, 1 and 12 are factors of 12. And with the same logic, I can divide 12 with a 2 without a remainder. I can divide 12 with a 6 without a remainder. So, 2 and 6 also factors of 12. Same way, 3 multiplied by 4 is 12, which means 3 can also be the factor. 4 is also the factor of 12. So, see, already we have 1, 2, 3, 4, 5, 6 factors for 12, which means definitely 12 is not a prime. Then 12 is a composite number. Okay, now let's look into one small special number, which is none other than the big 1. Now, what is this one? Is he a prime or is he a composite? Actually, he is not both. He is not a prime, he is not a composite number. Because if you check the definition, a prime number should have exactly 2 factors. But 1 has only 1 factor, which is 1 itself. And if you check the next definition of composite number, a composite number should have more than 2 factors. Again, 1 is not having more than 2 factors also. So, 1 is not a prime also, not a composite also. It is just a unit quantity. Okay. So, once again, if I summarize, prime numbers are numbers greater than 1 which have exactly 2 factors, and those factors are the number itself and the number 1. So, some examples for prime, I'll just write it here. 2, 3, 5, 7, 11 and it goes on. So, if you can try to find more prime numbers from the multiplication table. So, you'll see the numbers which is exactly coming once or appearing once in the multiplication table are prime numbers. And one interesting fact I'm going to add here is, you can see 2 is the only even prime. Other than that, all are odd numbers. Okay. So, just give it a try. Go through the multiplication table. Try to find the other prime numbers. Okay. And composite numbers, once again, numbers that has more than 2 factors. Okay. So, I hope the concept of prime numbers and composite numbers are clear.